Today I'm going to talk about thiamine, which of course is vitamin B1 and a water-soluble vitamin. Before I begin, I do want to give a brief overview of water-soluble vitamins in general. We know they dissolve in water, they're readily excreted from the body and not stored. They are subject to cooking losses, so when you heat them, there are changes that occur. Many of them function as coenzymes and or participate in energy metabolism. A large percentage of B vitamins are absorbed, approximately 50 to 90%, and we tend to see marginal deficiencies versus profound deficiencies when it comes to the water-soluble vitamins, and generally speaking, they're non-toxic. I pulled this from your book. I think this is a great way to think about the vitamins, or at least organize them in your head. We have the fat-soluble vitamins, which we'll be talking about later. We have folate and B12 that are important for erythrocyte production, and then the vitamins associated with energy and nutrient metabolism, those associated with gene expression, and of course vitamin C, the powerhouse antioxidant. So just give that a review. I think it breaks it down nicely. The digestion, absorption, transport, and storage of thiamine or B1. It's in free form in plant foods. In animal foods, it's primarily occurring as thiamine diphosphate, and it must be phosphorylated in the intestine, hence the name TDP, and absorption is usually pretty high. Food sources I've listed for you: enriched grains, baked beans, cooked green beans, wheat germ, ham. There are some factors, anti-thiamine factors, that may prevent absorption. Thiaminases in raw fish. I don't think it's a good idea to eat raw fish in general. If anybody's watched Monsters Inside Me, it'll make you think twice before you do that. Acids found in coffee will inhibit absorption. It usually is absorbed in the midsection of the small intestine, so the jejunum, and it has specific protein carriers that allow that to happen, and it happens by diffusion. Alcohol interferes with absorption. I can't tell you the number of cases I've seen lately in my consulting work related to thiamine deficiency due to alcohol abuse. It's, again, as I said, transported free, bound to albumin, or as thiamine monophosphate, TMP. In terms of metabolism and excretion, most thiamine exits the body in the form of TDP, and or I should say it can be excreted intact or catabolized, either way. So in terms of functions and mechanism of action, it does play a role in energy production. If you flip back to that chart that I just showed you, you'll see it listed. It's a coenzyme. It synthesizes some of the pentoses and NADPH, and it also regulates sodium channels, which is related to nervous system functions. I've listed the recommended dietary allowance for you. Deficiency, when it comes to deficiency of thiamine, there's a couple I wanted to focus on. One of them is called beriberi, and there's 3 different types. Essentially, the difference between the dry and wet is whether or not you have edema associated with the beriberi. Wernicke's encephalopathy is usually occurs as a result of alcohol abuse. Folks present with ataxia, so difficulty in coordinating their movements, confusion, and there's some ocular changes that occur. To treat that, it has to be done in the hospital, and 500 milligrams of thiamine is administered IV, BID, or twice a day over a 3-day period to reverse the effects of it has to be caught in time, however, of the encephalopathy. So there's a picture of someone with beriberi, characterized by weakness, poor muscular coordination, and cardiovascular problems, and a wet beriberi would have symptoms of edema versus a dry, which would not. It's not stored, as I said in the beginning. Most of these vitamins are not stored, so deficiency symptoms can happen rather quickly. Initially, irritability, sleep disturbances, tiredness. I think that could be possibly anybody on the planet these days. It's rapidly lost in the urine. Again, they are water-soluble vitamins we're talking about, and there's no tolerable upper intake level. So toxicity really isn't something that we're really concerned about. In terms of assessing your status, your thiamine status, the erythrocyte transketolase activity is analyzed in whole blood. So they hemolyze the specimen, and they measure that enzyme activity of the erythrocyte. And that can be measured also in the urine. And that concludes the thiamine lecture. Please let me know if you have any questions.